Alright, today's lesson is lesson 5.7a, 5.7 part 1. We're going to be determining the number and types of roots for a polynomial equation. Alright, the first thing we're going to talk about is the fundamental theorem of algebra, which is real simple. Every polynomial equation with degree greater than 0 has at least one root in a set of complex numbers. Now, the key word here is complex numbers. We're going to be using that and our calculators today to do a lot of the work at the first part of your worksheet. All right? Solve this equation. State the number and types of roots. X squared plus 2x minus 48. All right, let's pull up the calculator. All right, we're going to want to open up a calculator screen here and go to the menu, select Algebra, Polynomial Tools, and Complex Roots. Now, we're going to put this equation in here, x squared plus 2x minus 48. X squared plus 2x minus 48. X squared plus 2x minus 48. Now, when you're doing this and you're using the complex polynomial roots, you want to go ahead and put a comma and then the variable one more time. That tells us that we're working with this polynomial and we want to find those roots. Click enter, and it's that simple. Your two roots are -8 and 6. -8 and 6. Now, I realize that you do not have the calculators at home, but come in during lunch, use the calculator, it won't take you that long. All right, so there are two real roots on this one. Let's take a look at our next example. You'll see something like this. Hey, pull up the calculator. Use that thing. Y to the fourth minus 256. So once again, algebra, polynomial tools, complex roots. Let's see here. That was y to the fourth. Make sure to go over, minus 256. Comma, our variable this time is y. Enter. All right, let's take a look at what we've got here. -4, -4i, 4i, and 4. So here are our roots. 4, -4i, 4i, and -4. Notice there are two real roots and two imaginary roots. Okay, simple enough. Okay, now back to our lesson. Okay, the next thing we're going to talk about is sometimes the calculator won't help you with some of these roots. So, the fundamental theorem of algebra, this is the corollary, and what it says basically is the degree of the equation tells you how many roots there are. Okay, so if it's a third degree, you're going to have 3 roots, fourth degree, 4 roots, and so on. Okay, understand also that sometimes these roots are repeating roots. You might have some of the same number. All right, but when we're working through a problem tomorrow on the next lesson, we're going to want to be able to find those roots, and we're going to use this thing called Descartes' rule of sign. Descartes' rule of sign. Real simple. If you know what you're doing here, let's look here. You're looking for sign changes. So here's the original problem. Simply recopy here. Now look at the signs. I went from positive to positive. There is no sign change. Positive to negative, yes, there's a sign change. Negative to negative, no. Negative to positive, yes. Positive to negative, yes. And negative to positive, yes. So when we count them, there are 1, 2, 3, 4 sign changes. So that means that as far as positives, I could have 4, but remember it could go down by 2. So there's either 4, 2, or none. Now, to figure out how many negative real roots you have, we want to look at changing the signs of just our odd powered things. So we're going to change that sign. We'll change that sign. We'll change that sign. Those are all odd powers. All right, so once they've done it, they've got it right here for us. All right, positive to negative, yes. Negative to negative, no. Negative to positive, yes. No, no, no. So you'll see we have two sign changes here. That means there could be either two or no negative real roots. All right, so that means that we're going to have some imaginary roots possible. All right, remember, we're going to have 6 roots total. All right, if there's 4 positives and 2 negatives, that means there are no imaginary roots. However, if there's 4 positives and no negatives, that means I've got 2 imaginary roots. If I've got 2 positives and 2 negatives, then there are 2 imaginaries. 2 positive, no negative, 4 imaginaries. 0 positives, 0 negatives, 6 imaginary roots. So your possibilities are 4, 2, or no positive roots, 2 or no negative roots, 0, 2, 4, or 6 imaginary roots. I'll take you through one here. Okay, step 1, for the positive roots, I just look over here and look for sign changes. Negative, positive, yes. Positive to negative, yes. Negative to negative, no. Negative to negative, no. There were 2 sign changes. That means I'm going to have 2 or no positive real roots. Now we're looking at negative real roots. I'm going to go through and change just the signs on my odd-powered terms. So that's going to remain x to the 6 because 6 is even. That's going to go to minus 4x to the third because that's odd. Even power, it stays the same. Odd power, remember that's a power of 1. It changes. And that stays the same always at the end. Now let's look for sign changes. No. No. Yes. Yes. All right, so as far as negatives, there are 2 or no possible negative real roots. So now then, we know we're going to look for imaginaries. This is 6th degree, so there's got to be 6 roots. If there's 2 positives and 2 negatives, 2 more roots will have to be imaginary. If there's 2 positives and no negatives, 4 roots would have to be imaginary. If there's 0 and 2, we've already got that accounted for right here, but if there's 0 positives and 0 negatives, that means we would have to have 6 imaginary roots. Tomorrow, we will be using these steps to help us find those roots. Thank you, and have a fantastic day.